Does it show it's recording on your end?
It certainly does, Bob.
All right. Well, I've taken a lot of heat over the last couple of days. I don't know if you've seen the comments on LinkedIn. It's not any better on Instagram or Facebook or any of the social media platforms. I am a Neanderthal. I am a ding dong and every other pejorative that you can muster, because I am anti-science and anti-progress and a gas guy that just doesn't see the future for what it's at. And so we got Robert Whitney, who's in the UK. Where are you at, Robert?
I'm in a place called Woking, which is the home of McLaren Formula One. And which is probably, I don't know, 10 minutes from Heathrow Airport. So I'm on the sort of southwest side of London, just outside of the main ring road of London, M25.
Oh, nice. I went to Montreal last year and watched my very first Formula One race, and was gobsmacked. It's an impressive thing. I'm not really a Formula One guy, but like, I guess what we're going to talk about here today is the technology there is unbelievable.
Yeah, absolutely. And you know, I'm a huge Formula One. I'm a huge car guy, and I follow the F1 very, very closely. I've actually been to see the F1 in Montreal. I've got friends in Canada. Great circuit, great place to go see it. And yeah, what I've seen really happen over the 20 years I've been in heating is a technology shift from very, very simple systems with basic boilers, on off, high temperature, voltage switching, 230 volt switching, to then 2005 condensing boilers came in, and you know, there was a move towards slightly lower flow temperature heating systems, and then literally in the last sort of 5 to 10 years, you know, the move towards more renewable fuels and mass electrification of heat has been really the thing that's been pushing things forward in UK and in Europe. So I've seen this change of technology, you know, go from very, very straightforward systems to systems which are a lot more technical, a lot more design led, and a lot more complicated to specify and install, and also a lot more difficult for the customers to actually get the best out of and to know whether it's working well. So yeah, it's been huge changes in the last 20 years and in the last 5 to 10 years particularly. And heat pumps are a real Marmite topic in the UK. And as you've seen, there's almost like two sides of the fence, and you either really, really love them or you really, really hate them. There's no middle ground. And what I'm hoping we can do in this chat today is to find a bit of a middle ground. You know, there's no right or wrong technology. There's only right or wrong application of technology. And all of these different inventions and systems have their own place. It's when you start to try and use them out of their design intent that things start to go wrong.
Yeah, and just there's nothing there that I could counter or disagree with. Like you say, my biggest challenge, and what sort of spurred the discussion, is me saying governments are forcing people to do this. And that's a big word, and you know, it's the internet, so you have to say big things to get people to look at you. But you know, the mandates that certainly here in Canada, that the push for that, and the incentives by governments to manufacturers to get that product out.
Yeah.
Where particularly in my little world, you know, our weather extremities make those heat pumps really all like a non-factor at this point. You know what I mean? Like, technology's getting better, blah, blah, blah. We can go through a couple of points that we sort of listed out here, but
yeah,
it's not really there yet.
I mean, in the UK, we have a mild temperate climate.
Yeah.
It rains a lot. It's quite high humidity.
Yeah.
And when you design a heating system, you do your heat loss calculations and you size the heating system for the worst week of the year. Where I live in England, that's -3 degrees C. So we don't get very, very cold. It can go to -10 degrees C perhaps, but and very, very rarely it snows. And obviously your climate's very much harsher than that. You get really
Our
deep
design temperature is -40 C.
Yeah, exactly.
And when we design our systems, that's like you say, you got to prepare for the worst.
Yeah.
And so when you do, and then when I do that with a heat pump, I'm like, okay, well, that's garbage because I can't use it.
If we had -40 in England, people would be like never leaving their houses and screaming, and the whole country would like grind to a halt. So interestingly, -40 is the same on the degree C and degree F.
Yes, it is. I've said that to people.
Yeah.
What do you told us? I'm like -40.
Yeah.
They're like C or F. I'm like, it doesn't matter, dude.
No,
the fact that you asked me that question tells me you don't know what you're like. You don't. You're the ding dong, not me.
Yeah. So like in the sort of European area where we are, obviously we've got continental Europe, and then we've got the sort of Scandinavia, the Nordics. Heat pumps are like mass deployed in Norway, Sweden, places like that. But they tend to use what we mostly know as air conditioning there. They don't have hydronic radiators generally. They just use air to air. A bit more like the sort of traditional systems we have a central air, but they have cassette units everywhere. And when they have like super cold days, the efficiency of those heat pumps goes like almost 1-to-1, almost direct electric. But then what they do is they have backup fuel, and they have wood burners. In UK, our climate is quite mild, so the heat pumps that exist today, they'll satisfy the full heating and hot water demands 365 days a year, no problem at all. And in continental Europe, it gets a bit colder in places like Germany and Poland. They will then go to backup electric heaters on top of their heat pumps. So,
which is truthfully the worst, or the worst heating. Like it's the least effective. From I mean, that's what they call it. They call it resistance heating.
Yes.
Right. To which is the word to make it like sound different than what it is. Like
direct electric.
We've all lived in the apartment when we were young and trying to figure it out, and had to, like, the heat wasn't working, so you had to turn on the stove. And put a fan on the stove to try and heat your place up a couple of degrees. That's electric heating, resistance heating.
I guess the difference and you're absolutely right about that. It's 1-to-1 efficiency. I guess the difference in the way that's put forward now is that, particularly in the UK, we've done massive amounts of renewable energy. We've got huge solar farms and huge wind farms, and there's lots of times in now, particularly in the summer, where there's more electricity than we know what to do with. So you are actually have these agile tariffs where the use and the consumption of electricity at certain times, you will be effectively paid to use that electricity. And as that renewable electricity becomes more and more plentiful, obviously in the winter, there's going to be a lot less solar, but there's really high winds. We're in a very exposed island. In the North Atlantic, so we're surrounded by wind, so we have lots of wind energy, and having a grid which is mostly renewables and only topped up if it's needed with the gas-fired power supply stations, all of our coal-fired power stations have gone now. The last one was decommissioned last year.
And I wanted to talk about that because what do you think that's going to do with the Iran war? Like, you guys are going to be. So I'm just looking it up.
Yeah.
What you're saying, because that's what people do to me. So
Yeah.
currently you're at 30% wind.
Yeah.
28% natural gas.
Yeah.
12% nuclear. Biomass and hydro is 8%. Solar, and then net imports is 10%.
Yeah, and there's a pathway to what's called Clean Power 2030. It's a big government buzzword.
Yeah.
That will
2030
be
is a big year. There's a lot of things happening in 2030.
Yeah. And the idea being is that the national grid is essentially zero carbon grid by 2030.
And so I did a little bit of, I'll be looking into it. Like that was Germany's path, and they've actually brought coal back online.
Yeah.
With what's happening in Russia, and obviously what's happening in Iran. That's only going to that I think that trend is going to continue. What's your thought on that?
Yeah, so a large amount of the more rural properties in the UK are not on our national gas grid.
Yeah, okay. Yeah.
So they're running off of oil, kerosene, aviation fuel, or liquefied natural gas, propane. So those guys really have had a shock. You know, the guys that are on oil boilers, their kerosene that they buy and store in tanks in their garden has trebled in price.
And is that because, I mean, I know obviously the market factors affect that, but what is your, like here in Canada, our fuel rates, like 50 base, just for easy math, 50% of my price per liter is tax.
Yeah.
Right? Whether it's excise tax, federal tax, carbon tax, provincial tax, right? GST, all that sort of stuff.
Yeah.
Line up to be, and it's all hidden in there. So I think it's, you know, whatever the hell it is now, $1.80 a liter.
Yeah.
I'm like, oh, but 90 cents of that is straight up taxes. Is that the same for you guys?
It's very similar. And also we've seen the prices at the gas pump skyrocket. But you know, it's the imported liquefied gas and the imported kerosene that have really gone sky high, because we can't source those locally. We've got no local liquefied gas and oil.
Do you guys even have oil fields?
We have the North Sea, which is 90%.
Oh, okay, sorry, yeah.
Which is 90% depleted.
Yeah.
So there is still some there, but we're scaling down our extraction there, and so there's the baseline, which is, you know, the gas that goes into our gas grid that still comes from the North Sea, but the people that are most exposed are, as I say, the liquefied gas and oil, which are imported. We make our own petrol, our own gas, you know, for the cars. But yeah, the getting more and more reliant on imports, unfortunately.
Yeah. And what's your sorry, I'm not asking the questions that we talked about, but
that's right.
I'm not trying to get you. What's the capacity of your electrical grid? Like, is it like the actual grid, like the transportation system to get it from your fabulous wind farms and solar farms to, so you've obviously got lights in your house. What's the capacity of that? Is it
I mean, the answer to that is it's a bit like book them and they will come. You know, it's one of those. And there's two things. There's the national power grid, which is like the arteries, and then there's the local networks and the substations. So what the plan has been is the future is electrification. You know, mass electrification of not only heating, but of transport as well.
Yep.
So there's that roadmap towards 2030 and towards 2050 to basically get everyone driving electric cars and have electrified heating.
Yeah.
And that is all going to sort of happen over a time frame. And what we're promised is that the national grid power generation is, we're going to have renewables more than we can ever use. That's really going to be growing out as sometimes obviously there's more than we can use, and actually they have to turn off the wind farms at certain times. But we export both ways with Europe and with the Nordics. We've got big cables under the ocean that transfer it. But yeah, the ability for that electricity to then flow through the local networks into our homes, that is a bottleneck. It's recognized as a bottleneck, and that will be progressively increased. So when someone wants to get a heat pump fitted, or to fit a home battery or electric car charger or solar, they have to apply through the installer to the local network for permission to connect. And as part of that review, the local network just looks at the cables and the capacity to see what's possible,
if it's even possible.
Yeah.
And does that, I mean, is that just sort of a perfunctory thing, or do people actually get denied?
Yeah, you have to put forward a very, very careful application. Put forward exactly.
And it obviously costs money.
It doesn't actually cost money. It costs
time.
It doesn't. So time is money, but it is free of charge to apply. And the process is quite straightforward, but you need to be an engineer, a technical person to do that. And you have to basically list all of the other electrical things that are in your house. So if you've got an induction hob, EV charger, all this sort of stuff, and they may need to come and make some changes to your supply, fit a higher ampage fuse, something like that.
What's your typical amperage per in a home? Like, what is your? I realize we have different systems, but what's your breaker box like load bearing?
So we run on 230 volts AC, and it's most homes are single phase. So the usual cutout fuse next to the meter will be anything between 60 and 80 amps.
Yeah. Ours is 100.
And you can get that increased up to 100 usually. So what that means is that for most typical homes, they'll be able to have a heat pump, a solar array with an inverter, battery, and an EV charger, all within that 100 amp supply. But it starts to get quite busy, and you have to have devices which level the load if it starts to overload. So yeah, that's moving the amount of energy that used to come in through the gas pipe to do the heating and cooking, putting that onto electricity. It's a huge change, Bob. It's going to be a massive infrastructure project for decades.
For decades and decades.
Yeah.
Right. 100%. And so, everybody tells me, which I understand. I've installed heat pumps. I work on heat pumps. I understand the tech. Like, I'm not coming at this with some weird naivete, but one of the things that's interesting, and every industry does it. You have your COP, like your coefficients of performance, which everybody's like, it's 3 or 4 or 5, Bob. You're losing your mind. And then once it gets down, like you said, once it gets down to minus, here they tell me, well, it works up to minus 15. And then it's like 1 for 1, and then the resistance or gas heat takes. So usually it's gas heat. We have the backup boilers.
Yeah.
particularly in Western Canada because we have so much gas.
Yeah,
But then there's this weird little thing on the side that's called SCOP.
Yeah.
What's the difference? Because it's big.
Yeah. So, and I hate this terminology. Right?
So do I. It's so obscure. Like when you try and line things up, I'm like, no, it's different, but it's the same. Like, no, you're talking in a totally different language. And my conspiracy theory guy myself is like they do that on purpose, so we can't literally. It's not 1 + 1. It's literally calculus is what you're doing, trying to figure out what's what.
It's I hate acronyms to start with, but
that is a change that's not going away. I'm afraid.
No, but COP stands for coefficient of performance, which sounds like something some nerd would say, right? It's not.
It is. Some
not
engineer somewhere
language,
came up with it,
right?
Yes.
So, what in real terms, what it means? So, if there's a COP of 4, what that means is for every 1 unit of electricity, you get 3 additional units of energy produced. So you get 400% is the original 1 unit that you put in plus 3 free, which you've harvested from the environment, be it through recovering from the outside air or through a pipe works in the ground or even in water. And a good COP for a heat pump is between 3 and 4, so 300 to 400% efficient. All that changes when you put the S in front of it. The S stands for seasonal, so it's an average over the year. Obviously, the efficiency of these units degrades slightly when it's super cold, but when it's warm, the temperatures in the teens. It's sort of the springtime, the shoulder season, as we call it. Your efficiency will go up because you're able to extract a lot more energy from warmer air. I can tell you the sort of story I've gone through. So
I love stories.
Before we started recording, we were talking about people being guinea pigs. Well, I was one of those guinea pigs. The heat pump that's here was installed by the government on a funded experiment, essentially.
For free. Did they give it to you for free?
Yeah, for free.
Basically? Yeah. Okay.
In exchange for, 3 years worth of monitoring and feedback. And I thought, well, great, I can find out what all this stuff's all about, what it's really like to live with, and, what the experience is for people getting it installed, etc., etc. When my heat pump was installed, its efficiency was very poor. It was quite a cold time of year. It was February. Our winter is December through to February. So it was less than, it was freezing.
Lots of toques and jackets in the house.
I had 3 weeks with no heating. So I just had little heaters around. And as it was commissioned, as it was set up, the efficiency of the heat pump wasn't great. It was 2.4. I then started a journey which got me to where I am today, learning all about this equipment and what's good and what's bad. The commissioning hadn't been done quite right. I made some changes, got it up to 2.8. And then over the next couple of years, joined some of the installer groups and some courses and found out how to really do it. Got it up to 3.7. So that's now a sweet spot. And when we talk about the break-even point, unfortunately, there's still a huge sort of disconnect between the cost of the fuel and the efficiency. So to have a break-even point on a heat pump compared to gas, your SCOP has to be 3.7. Because effectively
the entire year.
Electricity is about 4 times the cost per unit, kilowatt hour unit, in the UK. So you do have to have quite a good performing heat pump to make it sort of at parity. The things that's changing about that now is these electricity tariffs, which are different prices at different times of the day.
Yeah, peak and peak load, or whatever you guys, we call it. I think they call it peak hours or peak performance. I can't remember the exact terminology, but
yeah. So the government kind of caps electricity and gas costs to keep it affordable for people. And our price cap at the moment is, I think, is about 30 pence. My tariff varies throughout the day. Overnight hours, I think it's down to like 11 pence.
okay.
My day rate's 20 pence, but my evening rate between 4 and 7 p.m. is like 40 pence.
Yeah.
Like, they really don't want you using the electricity then. So
how, do you have like timers and stuff in there? Like, I've talked to people that literally have all sorts of little gizmos and gadgets to switch in and out.
Yeah. So, and this is another part of it, Bob, is, you know, asking people to like be anal about how they live their life. Yeah. That's not going to work for people, right?
Not gonna. I agree with you 100%.
It's not going to work.
People want it, like, not to interrupt your story, but I literally had somebody says, dude, you don't understand. Everybody wants the convenience of it. I'm like, yeah, everybody wants to plug something in and just have it work.
Yep. Yeah.
And unfortunately, as your experience is, at the current, where we're at right now, that's not the case. Where you literally, really, if you're going to get the most out of it and do what the white, coated engineers say, then you have to be anal about it.
You do, unfortunately, and we're still at that early adoption phase. And most people that have got heat pumps, they sit in 2 camps. They're either nerds like me, or they've had the system fitted for free on a low income grant type thing. And where it all needs to get to, it needs to be a lot more sort of, the user experience needs to still be improved a little bit. And where it will get to is that all this stuff like ramps up and ramps down automatically, and it will be, matched to the next thing. I'm going to use another set of acronyms. The next thing you'll start to hear about is HEMS, Home Energy Management Systems.
Say that again.
HEMS, HEMS.
Okay. And what is that?
It's Home Energy Management System, and what it does is matches the production of electricity and the grid. It follows that, and it uses what's called flexibility in your electrified home to use electricity either more or less at certain times of the day. Okay. So, painting a future.
It's another app.
It's another app. Yeah. Yeah. It's another app. But this app is one app that does everything. So one app to rule them all, rather than rather than today.
An ominous reference, isn't it?
Yeah, I mean, I've got like an iPhone, and there's groups of apps. Like 10 apps for all the different things, and that's all right for a nerd like me, but not for normal people.
So that here's okay. No, I love that. And so, what is just same thing, but a bit of a shift? Like, what is your trade influx like? Like, are people moving into the trade to be able to install this stuff, or are you seeing a deficit like we are? Like in North America, for every 10 dudes that retire or get out of it, there's like 4 that are going into it. Is that similar?
Yeah, we got exactly the same problem, and most of the guys that are plumbing and heating engineers, they're my age, and a lot of people don't want to be on the tools any longer. The bodies are like crying enough, so there's a whole new generation of low carbon electrician stroke controls type specialists that are going to be needed, and that's not really happening, and it will really hold back the rollout of this technology.
And so you have two things happening at the exact same time. As you've just described, these systems become more intricate, more complex, more sophisticated, that require a higher level of, dare I say, intellect, experience, education, in order to get those numbers that you need in order for them to be efficient. And, you know, the tech's doing this, or the technology's doing this, and the technicians are doing this, is from just about every metric that I see.
Yeah, they're dying out, Bob, and they're not being replaced quick enough. So if you look at the gas engineers that, you know, fit and take care of boilers here, only about 20% of those are interested in fitting heat pumps. And are reskilling to fit them. It's not necessarily the fitting that's the issue. It's the system design. So you know, we started talking about, you know, the transition of boilers from basic on off to condensing and lower temperature. And the boiler and heating systems changed from being a furnace with a separate storage tank to a integrated unit called a combi boiler back in about 2005. So the knowledge and the skill set of a heating engineer sort of started to like disappear a little bit. It sort of turned into more of an appliance box shifting thing. What now has to happen with the heat pumps, it's not just an appliance change, it's a rediscovering heating engineering change. And having to do room by room calculations. And also to what it means when you retrofit a heat pump. You know, there's some repiping and some radiator emitter changes needed as well, because basically you're going from a higher temperature system with quite a wide delta T to a lower temperature system with a very narrow delta T. So actually your flow rate of warm water that goes round has to quadruple to get the same amount of energy. And you also have to leave your heating running basically most of the day to get enough energy through. So it's a complete
to make it to the peak moment where you can shut it down. So you can have your beans and wieners with
that's it,
just a shirt on, and then when you're ready for bed you can kick it back in. Is that how that works?
So the homes and the properties in UK, they're quite leaky. You know, they're not.
That's another thing. So we have here, it's called R2000 builds, which means you have some I don't want to explain it to you if you already like. It's just they're very tight homes. Right. We go from back when I started, you were allowed to have about 3 feet of hole in your entire house. Right. And now it's like 3 inches is what's allowed because it's super tight. And you know, you guys have homes that are 100. We might have a home that's 50 or 60 years old. Type of thing. On the regular, you guys got ones that are 100 years old.
We do. I mean, the majority of the homes are fairly modern. You know, the large house building went on, you know, after World War II, and most of the homes are of a decent standard now. But they're not. The thermal performance is not the same as ones that you would see in Germany, for example.
Yes.
So they do lose heat quite quickly. And the traditional heating systems have been designed to have quite high output.
You know, oversized.
People will run their heating typically in England for a few hours in the morning and a few hours at night. And for the heat pump systems, they're generally designed to be, rather than providing heating to heat up and cool down, they're designed to provide, like, they balance the heat that's being leaked out with heat that you put in to keep a level. That's the difference in approach.
Yeah, it's very similar for us in that, like, we do lots of hydronic heating,
Yeah,
and that's our approach is, like, we like, don't turn this like, take out your time thermostat
yeah,
and pick the temperature that you want and just leave it.
yeah,
So this thing
exactly.
will just sort of coast, just, along and give you the comfort that you're looking for. It's easier on your heating bill, it's easier on you. The blast furnaces that were very popular,
Yeah,
from World War II to, we'll say, 2000, we'll say.
yeah,
We're just like, we'll just like, when you come home, turn it up to 22.
yeah.
In 8 minutes, it'll
Full
be
afterburner. Let's go. Yeah,
roasting in here, and then you
yeah.
can turn it back down, and then you know what I mean. And it just sort of, as like a fire, just sort of dissipates out.
Well, it sounds like actually that you're a bit of a step ahead of most of the engineers in the UK then, because if you're used to lower temperature
Yes.
hydronic system design, you'll be absolutely ready to fit heat pumps.
No, I listen. I Despite what people call me on the internet, I'm not retarded and I'm not a Neanderthal. Like I understand how this stuff works, and
Yeah,
I am a proponent of using our resources wisely,
yeah,
and making sure that as the customer is getting the best value for his money.
yeah,
Which comes into the next thing. You obviously work on your system.
yeah,
What if you're I don't know what the day rates of getting a heating engineer out to your house is, but all the energy savings go out the door the second I show up. Like if I'm showing up on, whatever, like you're going to spend somewhere between $400 and $700 for me to address whatever your problem is. And when I look at the savings, they're like, well, you're going to save $500 to $600 a year on your heating if you put this in. I'm like, unless I show up, and then it's all out the door.
yeah. I mean, I've seen a big shift in the way this sort of electrified tech is sold over the years. And rewind 5 years, it was all about the environmental impact and the reduced carbon
Yes.
emissions, right? The narrative now is completely switched to, is this going to protect me from shifts in fuel prices because of international
Yeah.
conflicts? Is it going to be, if I can fit some solar panels and have a home battery, how much is my bill going to reduce?
Yeah.
That's the narrative these days. And the heat pump systems, because the heating systems are still stuck in the 1980s, still with fairly small radiators, high flow temperature, on and off for a few hours.
Yeah.
That sort of technical debt has to be caught up for when you fit a heat pump. So generally there's a retrofit project to update the hydronic system. And that's why the heat pump retrofits are quite costly still in the UK. We have a grant system to support them, and that is quite generous. So,
what would be your average install or upgrade cost, do you think?
So the average cost in UK pounds is about 12 to 14,000 pounds.
Okay.
The grant pays for about half of that. If you are now off grid, and you're running on oil or LPG, that is 9,000. So they put that up recently in response to the conflict in the Strait of Hormuz. But yeah, it still is quite costly to have those systems retrofit, and you only get that payment once. And we're starting to see heat pumps which were installed 15 years ago dying now, and people are having to pay a lot to get that replaced.
And so with that change, as one of the questions I gave you was, we're obviously changing refrigerants. Is that happening in the UK for you as well? Are you guys changing to the what is it, 454B?
Yeah, so we used to have R4 410.
410.
that changed to R32, which is the R32 you see in a normal aircon unit.
Yeah.
The latest generation heat pumps that started to be sold in the last couple of years are now what they call natural refrigerants. It's actually propane gas.
It's propane gas.
R290. Yeah.
Yeah.
So those heat pumps, they operate at the flow temperatures a lot more like a furnace.
Yes.
And those can, really work and quite well and heat up more like a boiler system. So if you don't want to go to a full low temp system and change your pipes and fit larger radiators, those can work, at more like a boiler temperature, but you do then trade off a bit of efficiency. So yeah,
it's interesting that it's going to basically a fossil fuel, right?
A fossil fuel that's not burnt though.
No, I get it. 100%.
Yeah.
No qualm with that there, but it's still like we still need to go get it, right? Like it's not like wind or solar. Like we still have to drill or whatever, or mine or whatever we're doing.
And that's the thing. It's like oil and petrochemical industry is not going to go away.
It's not going anywhere.
Everything that you buy or use has oil in it, or has been used to produce it, or the clothes we wear as well. The movement is more towards oil is finite. Let's use it to make things rather than just burning it.
We can talk about whether oil is finite or not some other day if you want.
Well, it's how hard we want to look for it, isn't it?
It's true.
Yeah.
But so I guess my point of having the propane in it, like that, and for me and for you, I suspect the risk is minimal. But like you say, as we experience this trade deficit of actual competent, skilled, trained, educated tradesmen, you're going to have, some donkey come in there and work on your system with propane in it, and the risks of things going sideways increase as quickly as your COP does with efficiencies. It goes from 1 to 1 to like 4.
Well, thankfully, it's all a contained unit. So
yes.
The heat pump now are what's called monoblock systems. So all of the propane just sits in the outdoor unit, and it's just a very small, a few liters of gas. You're not having to run refrigerant pipes into the house or into a an interface unit. It's all a sealed unit that's outside. But there are certain other precautions that have to be taken to recognize that has a flammability risk.
I think here they're actually making us take like you have to be certified to work in it now, which is I haven't done it yet, but whatever the training course is, I don't know if it's you show up for an afternoon and have donuts and walk away with a sticker, or if it's a little bit more in depth on how to work with those things. Is that happening over there too?
Yeah, to install a monoblock heat pump, as it's called, air to water heat pump, you don't have to have the refrigerant gas training for that. But if you want to service and fix and maintain them, then yes, you do. But that refrigerant gas training really was for the legacy of it is for refrigerant gases which were high ozone depleting gases.
Yes. What do they call that? The GWP or something like that?
Yeah, global warming potential.
Yeah.
So
another accurate. We're nailing them.
Another lovely acronym, Bob. But I mean, it's a fascinating subject to discuss, and there's been lots of push from the manufacturers, from the government, and from other influential bodies to get everyone thinking in a different way. I'm a bit kind of agnostic to all this stuff. I'm an engineer, and I exist to understand technology and to apply it and get the best out of it. And I'll advise people what's best for them. And
No, I think that I think you're right. Like I say, my only, which is what was sort of what the whole purpose of that my little stupid thing was like the with the governments are incentivizing people to do this stuff.
yeah,
Here in North America, we're still at basically 55% natural gas creates our electricity, and so when I say it's a fallacy, is because you're creating electricity at less than 40%.
yeah,
And then over here, you're saying I'm saving it. I'm like, yeah, and this your end result's fabulous, right? You're being very efficient over here, but to get to this, you're killing Bambi and butterflies over here to make so you feel good, 400 kilometers away.
yeah. I mean, we're treating gas-fired power stations as a bridge technology at the moment, as a backup technology. And as I say, we closed our last solid fuel power station last year.
Here's a question: do you think that's going to come back online with what's happening in the world internationally?
No, they're all gone. They can't be restarted. They're fully decommissioned now. We've replaced that combustion power supply with biomass, and there's a large facility in the north of England, power station called Drax, and there's
I don't know anything about. I will. Full disclosure. I don't know anything about biomass.
It's worth looking into, and it's a bit controversial. It gets huge subsidy from the government, and actually the biomass.
Yeah. What's the project called, so I can look it up later?
Is the 007 movie Moonraker?
Yes.
You had Drax there.
Oh, okay.
The same. It's about the same.
Okay.
And they get huge amounts of government subsidy to create this so-called clean electricity from biomass.
And so do they just pile a bunch of, we'll say cow poop in there, and it just creates its own heat, and
no,
off we go?
They're burning trees, Bob, and they're burning trees that come from Canada and other places. And
there's where my softwood lumber is going.
These are not just like
wow
trees that have been raised to create fuel. They're some mature trees as well. So there's been some scandal about that. So
I bet there is. Yeah.
Like all this stuff, there's good and bad. But
yep.
As I say, the trajectory is renewable. It's either solar or it's wind, and there's huge amounts of investment in offshore wind.
I saw the one. Somebody directed me to the one that's in Denmark, where they have like the world's largest heat pump that's running off the ocean, or is it a river? Might be a river. Oh, I think the first one's in the ocean, and then they're creating another even bigger one.
Yeah,
that's supposed to be powered by the river.
Yeah, and we trade, across borders electricity, and obviously with the rise of the AI data centers, they're going to need huge amounts.
That's the other one we haven't talked about, right? Like, where's all that power coming from?
Well, I don't know if you know, but the nuclear plant in the States that had a meltdown, they've resurrected that one to provide.
Yeah, it's now an AI data center. Like, is that like? I don't know how ironic you could be. Take 3 Mile Island that was the reactor that blew up, and now it's safe because it's an AI data center. Is it safe? Like you said, the one ring to rule us all is we're feeding that beast like crazy. Are you guys having that same sort of discussion about AI data centers in the UK?
Yeah, and they're trying to reuse the heat that they produce for heating homes, and all of these are great ideas, Bob. worked in a number of different roles over the years, and I've sat on some of the government working groups as well in the standards making bodies. So I understand the ambition. It takes a lot to change those policies into workable, commercial reality.
Yeah. And so are those, I mean, we're coming up on our hour here, but and I'm happy to, sort of go around too if that's something you're interested in. But
Yeah.
Like it is the 2030 and the 20, like here in Canada, they've already sort of behind closed doors, 2030 is done. Like we're not going to make any of those targets. It was very ambitious, and now we have to recalibrate. And I think the new one is, here in Alberta, we're talking 2050, where we're going to use hydrogen gas. And nuclear is now a conversation, which I'm actually a proponent of. But
yeah, nuclear is back on the table here. Yeah, nuclear is very much back on the table. There's some huge nuclear stations under construction. There's no one technology and there's no one fuel that's going to be the panacea. So it's a case of applying the right technology in the right areas. Electric cars is, as I said, I'm a big car guy. There's been a huge push for electric cars in the UK as well.
How's that going?
It's really starting to take off now.
Is it?
Yeah. And that technology has kind of got over that sort of problematic front end. They are actually really good and good range and affordable now. They're the same price as a normal gas engine car now.
This is totally what we weren't going to talk about, but as far as I think, isn't it GM and Toyota and even Honda have decided not to produce those anymore? Aren't they out of the market of that?
Yeah, a lot of
the ones left are Tesla and I can't remember the name of the other one.
Yeah, there's been a lot of write-offs of development projects on electric cars. So the big group in Europe is called Stellantis.
Yes.
And they have.
You guys have a plant in Canada, Eastern Canada, I think.
Yeah, and some North American brands as well. They recently wrote off crazy numbers. I think it was 20 billion in value, because the demand hasn't really caught up with what's being pushed. So all these technologies are great if there's the market demand for them. If they're force fed onto people by either the manufacturers or the government, and the technology is not mature enough and the market's not ready for it, there's a mismatch. And there's been a bit of that, I'm afraid to say. And it's put people off it, sadly.
So just to sum up, then, at the end of the day, I'm right and you're wrong.
Yeah, I mean,
no, I'm kidding.
there's no good and there's no bad technologies. It's how you go about it and how you bring it to market. So you can make anything fail or make anything succeed, depending on your motivations.
Carrot or stick, right?
Yeah, the heat pumps have got their place. I think they're a lot more suitable for the UK market as a standalone than they are for Canada. But I know you get hot summers as well. So if you can use the heat pumps for your air conditioning.
No, listen, I like, there is certainly a place for that. And there are mild places in Canada, no doubt about it. We just happen to live, my environment is just the extremities of those temperatures. Make it, as far as to my customer base, I'm like, I think it's unusable for the time being. They've come out with cold climate ones that say they work for another 10 degrees below. You look at that, I'm like, okay, that sounds good. Does it really work? Like, am I going to be able to convince my customer to spend 20 or 30 grand on a system and then have them not phone me all winter long mad at me?
Well, this is the thing, is you have to prove this stuff to yourself. for your own
Yes.
experience, not just going off of what some salesman
Yep.
or some government politician has told you is good. You know, you're
Yep.
an engineer, I'm an engineer. We field test this stuff before we endorse it.
Yeah. No, and I think that's exactly what you've done, right?
Yeah, that's exactly what I've done.
Is walked the path of the sad man and
Yeah.
figured out what was wrong.
Yeah,
And
I've
fixed
had
it.
the pain, and you know, I've had to dig deep and work out how to fix it. And I'm now I've now started up my own business in the last few weeks to be a troubleshooter for people's heat pumps.
Good.
To go and help them to get them working as they, you know, for the potential that they've got. So all this technology can work really, really well. I think what we can agree on is there's a bit of a mismatch at the moment in a lot of people's experience.
Yeah, that's great. I would be interested to see how that goes. If you've just started off, we should touch base in 6 months or so, and you can tell me if it was a miserable endeavor or you're, you know, taking over the world.
There's plenty of opportunity out there to make things better, and
that's
what
the beautiful thing about the sort of the trade world, right? Is that or the engineering world, that there's so much opportunity, and if you approach it the right way with the right attitude, then you can be of service to a great many people, which I think is what is our intent when we get into this thing, is to be useful and to make a couple dollars to support ourselves and our family. So I think that's awesome.
Absolutely.
That's awesome.
It's been great to chat to you about all these things, setting a few things to rights, and I wish you well, and I look forward to seeing the podcast.
Yeah, I'll just stop recording here for a second. We can have a quick chat.
Yeah.